All right, so we are back for lesson 6.2, day 1. Time for a raise. Mrs. Gallus's employees have been working very hard, and it's time that she give them a raise. She's trying to decide if she should give everyone a $10 raise or if she should double everyone's wage. So we have the data from yesterday's lesson, and that gave each wage and the probability of getting that. If you recall from that lesson, the mean we found by taking every value, so that's all your xi values, and multiplying by their probabilities, and then we added them all together and got 750. A little bit more in depth was your standard deviation formula, and that was the square root of all of your xi's minus the means squared times their probabilities. And remember, I'll change the color so you remember that you have to then add those all up as well and take the square root so that you actually have the standard deviation and not the variance. So what we're going to take a look at here is two options: adding $10 to all of the employees' wages or doubling the wages. So we're going to look at two transformations today and see which one has a higher value and basically how those play out. So if we were to do that, you adding 10 to each of these values, that gets you 11, that gets you 15, 17, 20, 25, and 35. The probabilities of getting those are still the same. So 5 out of 22, 2 out of 22, 10 out of 22, 3 out of 22, 0 out of 22, and 2 out of 22. So if we were to do some recalculating, you would see that you have the mean. You would get, so if I took 11 times 5 over 22 plus 15 times 2 over 22 plus 17 times 10 over 22 and so on, and added those all up, you would get 850 as your 850 as your new mean. So that's essentially taking the old mean and just adding 10 to it. If you were to then compute the standard deviation, which would be to take the wage, so 11 minus 850 and square it, and then multiply it by 5 over 22, and do the same thing for each one of those and add them all up and square root it, you would find that you would get the exact same standard deviation from before, which is 624. Which makes sense because we've talked about in the past that if you add a value to every data value in your data set, you're essentially picking up that entire distribution and moving it over, in this case, up 10. So that would give you an increase in mean, but it wouldn't change your standard deviation at all. So now let's take a look at what would happen if we would double the wages of all the employees. So in this case, a $1 wage would become $2, a $5 wage would become 10, 14 for the $7 wage, 20, 30, and 50. And the probabilities of getting those were the same. So 5 out of 22, 2 out of 22, 10 out of 22, 3 out of 22, 0 out of 22, and 2 out of 22. If you were to then compute those, you would find that your mean, after you would do, say, 2 times 5 20-seconds plus 10 times 2 20-seconds plus 14 times 10 20-seconds, and added and so on, and added those all up, you would get a mean of 24. Oh, I'm sorry, not 24. I was like wondering, I was thinking that doesn't make any sense. That is actually 2 mu, not 24. You would get a mean of 14, which makes sense because you would be, I'm gonna erase that because that's completely wrong. you would get a mean, and what I meant to say with that is 2 mu, which equals 14. For the standard deviation, because multipliers impact standard deviation, you would get a standard deviation of 2 times the standard deviation, which in this case would be 12, 1248. So your mean would be 14, 2 times the mean, and your standard deviation would be 1248. So then let's take a look at what questions. So how did multiplying by a constant affect the mean and standard deviation? Both the mean and the standard deviation are multiplied by 2. And if we were to go back up to that other, adding a constant, added 10 to the mean. So added to the mean, but standard deviation did not change. So there you have that. Which option would you prefer? There are a few different ways to answer this number 3. So I'm just going to discuss those. So the good thing about adding 10 to everyone's wage is that you get an increase in your average wage, and the variability, the standard deviation stays the same. So everyone increases, and you don't get a change in variability. In option 2, you have an opportunity for a higher wage, but there is a lot more variability. So on average, your wage could vary from the mean by $12, which means that you could potentially get a lot lower wage than that mean of 14. Whereas if you were using option 1, you have a higher likelihood of getting closer to that mean. So it just depends on that, like, give and take of whatever you would prefer. More variability, would you want to have potential to have a higher wage, but that also introduces a higher likelihood of you maybe potentially getting a lower wage. If you want a more consistent likelihood that you'll get a higher wage of $8.50, then you would probably want to pick option 1. All right, let's take a look at your important ideas for today. So adding the same constant to each value, let's see what happens. Let's talk about what happens. So adding or subtracting a constant. Adding or subtracting a constant, the shape will stay the same. Your center adds or subtracts that constant, which we could call C. Your variability stays the same. So you've learned this in another lesson back in probably chapter 1 or 2. It's just reiterated here with discrete probability distributions. If we're talking about, I'm going to pick this up and move it over here. If we're talking about multiplying or dividing, or dividing by a constant. And we'll call that C here as well. The shape will stay the same. Your center multiplies or divides by your constant, and your variability does the same thing. You're going to multiply or divide by that constant. Keep in mind, if we're talking about variance, so like this would be standard deviation. If you're talking about variance, then you would have to alter that variability factor by the square, because variance is in fact squared standard deviation. So that would be that constant, and your standard deviation would have to be squared, which gives you your constant squared times your variance. From here, we're just going to take a look at this discrete probability distribution. It wants you to calculate a lot of things that we talked about in the last couple of days. So if you have any questions, please stop into office hours, and I will see you soon.